Anytime an organism eats, it takes in matter and energy from another organism. Where does energy enter an ecosystem? Energy enters the living part of an ecosystem through autotrophs. Autotrophs are also called producers because they produce food. Green plants, some protists, and some bacteria produce food using energy from the sun. Some kinds of bacteria, like the ones that live in deep seas around hydrothermal vents, produce food using energy from chemical sources. These bacteria are called chemosynthetic bacteria. How do other organisms obtain energy and matter? Other organisms obtain energy and matter by eating living or once living things. They are called heterotrophs. Heterotrophs that obtain matter and energy by eating plants or other animals are called consumers. Consumers are of three types: herbivores, which eat plants, carnivores, which eat other animals, and omnivores, which eat both plants and animals. Heterotrophs that obtain matter and energy from dead and decaying organisms are called decomposers. Decomposers, like fungi, absorb nutrients from decaying organic matter. Decomposers like the earthworm and the millipede consume dead tissues on a larger scale and are called detritivores. How do decomposers help an ecosystem? Decomposers play an important role in recycling nutrients in an ecosystem. How can we show relationships among autotrophs and heterotrophs in an ecosystem? We can use a food chain to show the relationships among autotrophs and heterotrophs. A food chain shows only one path that energy and matter can take through the living things in an ecosystem. In reality, feeding relationships are a bit more complex. What feeding relationships can you identify between these organisms? A mouse may be eaten by a number of animals besides snakes, including hawks, owls, bobcats, and foxes. Snakes eat other animals too, including moles, which in turn eat grass and other plants. The interrelated feeding relationships in an ecosystem can be depicted through a food web. In both food chains and food webs, the arrows point in the direction that energy and matter flow, from the organism being eaten to the organism that is feeding. All these food chains show how matter and energy are transferred from one organism to the next in the aquatic food web, except Choice B is the one that shows an incorrect food chain. In the aquatic food web shown, matter and energy flow from the producer, algae, to the organisms at the next level, which are clams. Clams were left out of the food chain in choice B. In an ecosystem, how does the flow of matter differ from the flow of energy? Matter is continuously recycled between the living and non-living components of an environment, but energy is not. Decomposers help release minerals trapped in body tissues of dead organisms. Plants use these minerals to make plant structures, which can be recycled when the plant dies. Why does energy move in one direction through an ecosystem? This is because almost all energy in an ecosystem comes from the sun. As the energy flows from one organism to the next, it is transformed into different types of energy, such as mechanical, chemical, and thermal. But it cannot be recycled into sunlight. All organisms use energy to conduct life processes, like running away from predators, chasing prey, growth, and reproduction. A lot of expended energy is also transferred to the environment as heat. As a result, only a fraction of the energy acquired by an organism is passed on to the next organism when it is eaten. How can we diagrammatically represent the flow of energy through ecosystems? Scientists use a diagram called an ecological pyramid or energy pyramid to represent the flow of energy through ecosystems. Each step is called a trophic level. With energy obtained directly from the sun, producers contain the greatest amount of energy and form the first trophic level. Thus, they are usually the most abundant organisms in an ecosystem, providing most of the biomass or living matter in an ecosystem. The primary consumers have the most energy among consumers because they feed directly on producers. How much energy would secondary consumers receive? Secondary consumers have less energy available to them at this trophic level. Higher-level predators, or tertiary consumers, have even less available energy. Why does the biomass decrease as we move to a higher trophic level? With the decrease in energy from one trophic level to the next, it requires more organisms at the lower levels to supply the energy needs of a top-level consumer. This is why there is more biomass at the lower levels and less at the higher levels. In general, only about 10% of the energy moves from one trophic level to the next, resulting in a tenfold decrease in the amount of biomass. Which organisms would you expect to have the greatest biomass? An energy pyramid is used to represent the energy and biomass available at each trophic level. Producers make up the greatest biomass in the ecosystem. Let's run through all that we learned today. Matter and energy are transferred from autotrophs to heterotrophs. Food chains and food webs show the relationships among autotrophs and heterotrophs. Herbivores are consumers that feed on plants, carnivores are consumers that feed on other animals, and omnivores feed on both plants and animals. Decomposers help release nutrients trapped in body tissues of dead organisms for use by producers. This way, they promote recycling of matter. Energy cannot be recycled and moves in one direction. An energy pyramid is used to represent the energy and biomass available at each trophic level. That's all for now.